Are you going to be practicing drawing stars all class?
Look at how good that one is.
Here, I could draw the bus stop.
All right.
Isn't this a good
So take out your notes.
Isn't this a good
Yeah, it's great.
star? It is good for
Are you?
All right, so like I said, in this unit, we're going to be starting with just some basics of chemistry. It'll be just sort of a very short introduction. Next year in 8th grade science, you will spend some more time talking about chemistry. And eventually, once you get to high school, you may take chemistry as a class and obviously spend a lot of time. But this is just a basic introduction about chemistry. So chemistry is basically studying matter and how molecules and atoms interact with each other. Okay, and how, we learned in the end of our last unit about the chemical reactions of photosynthesis and respiration, where you have molecules where the atoms get separated, rearranged into new forms to form a new substance. That's what chemistry is about. Biochemistry is about the chemistry of living things. Bio means living. And so biochemistry is a chemistry of living things and that are in which chemical reactions are important to them. So first off, some definitions. Matter. If you think about everything in the universe, everything is either energy or matter. For example, obviously your desk is made of matter. The air that you're breathing in, that's made of matter. Water is made of matter. Your pencil's made of matter. Well, how about light? Yeah, light is a form of energy. Heat is a form of energy. Sound is a form of energy. Okay? So everything in the universe is either matter or energy. And our definition for matter is anything that has mass and takes up space.
Did you make that kind of air? Oh.
And so all matter, all of our surroundings that are matter, they're made of molecules.
Doesn't like light take up space and stuff?
No.
How does?
Because it's an energy, and energy doesn't take up space.
But then we're made of energy.
What's that?
We're made of energy.
We're take up space.
No.
The sun takes up space.
The sun is made of matter, but it releases heat energy and light energy. Just like a light bulb, the material of the light bulb is made of matter, but when it's electrified, it releases a type of energy, light energy. So matter is made of molecules, and what a molecule is, it's basically a tiny piece of something. Okay? It's the smallest piece of matter that you can have, and it's still the same substance. And I'll explain that in a second. Just get it down first. For example, if we think about water, so, I have here my water bottle. It's filled with water. So that water that's in this bottle is made of, there are billions of water molecules in this water bottle right now. Now, if I use a pipette and I take out a tiny, tiny little drop, is that still water?
Yes.
Yes, it's still probably thousands and thousands of individual water molecules. If you were able to keep separating that water droplet into smaller and smaller pieces, eventually you can get to one single water molecule. And that's still water. It has all the properties of water. Okay? But that's the smallest piece of water you can possibly have. We just need to, in this equation, put write this word reactants and products on whichever side they go on. So just write the word reactant product, whichever side they go on. So that's one water molecule. If you have that one water molecule and you split it into smaller pieces, well, you no longer have water. You have something completely different. So that's what we mean by it being the smallest piece of something that's still the same thing. But even these molecules, a water molecule is made of a smaller part called an atom. Okay? An atom is the building blocks of all matter. So what kind of atoms is water made out of? Okay.
Water molecules.
But what is one water molecule is made of two different types of atoms? Yeah, what does the H stand for? You know? Hydrogen and the O?
Oxygen.
Yes. That's one water molecule. It's made of one oxygen atom bonded to two hydrogen atoms. Okay? So atoms are sort of the building blocks of all matter. And molecules are made of atoms.
Cool.
All right, well, let's talk about elements. I know in elementary school you learned about elements before. An element is basically a pure substance. A substance that's not made of anything else. Water is not an element. Because what is water made out of? It's made out of two other things. Rena? Yeah, it's made of hydrogen and oxygen, so it's not an element. Could somebody name an element? Tim?
Wait, I know it. Oxygen.
Oxygen is an element. Oxygen is not made of other things. It's just oxygen. Logan?
Carbon dioxide.
Not carbon, because that's made of carbon and oxygen. Jaden?
Iron.
Iron is an element. It's just iron. Trina?
I forgot what it's called, but that thing in the balloon that makes your voice speak.
Helium?
Yeah.
Yes, helium's an element. Yep.
Carbon.
Carbon is an element. Michael? Gold is an element. Yes. So all these things, these are all pure substances. They're not made of any other thing. Okay? And they can't be separated. You can't take a piece of gold and separate it into anything other than gold. It's just gold. Carbon is an example, and all those other things you guys know. And we won't really use it this year, but you will next year. We have a list of all of the elements that we use when we're studying chemistry. You know what it's called? Nick? Yeah, the periodic table of elements. It looks like that. In the periodic table of elements, it's a list of all the known elements. And it has all those things you guys were just naming. Okay, gold and oxygen and carbon.
Like, there are empty spaces, but how do they know they exist if they haven't found it yet?
Well, all of those they have found. But there are new elements that are created in particle colliders and stuff, but pretty much all of the common elements on Earth have been found and discovered. When the periodic table was first put together in the 1800s, there were gaps in it that scientists thought there should be something here, but they hadn't found it yet. But later on, they did find those things, and they fit in perfectly with the periodic table.
What does the periodic word mean and what the whole thing? Like, does it mean?
What does periodic mean?
Yeah.
Yeah, it means that they are, when you have, period means like a cycle. And so when you have things in the same column, because they repeat, they have similar properties.
Okay.
So things in one column all have similar properties because of the arrangement of their electrons. Okay?
Doesn't hydrogen have the atomic number of 1?
Yes, hydrogen is atomic number 1. Helium is 2.
So isn't like this way family in this
Yep, groups.
way as group?
Yep. All right. But we don't need to really worry about any of that. So all you should know, elements are pure substances. But elements get combined, like hydrogen and oxygen, to form compounds. Compounds are two or more elements that are chemically joined, bonded together. So for example, glucose. Glucose is a compound, C6H12O6. It's made of 3 different elements combined. And one interesting thing is that when you take elements and they form compounds, often the compounds have very different properties from the original elements. For example, if you take sodium, sodium is an explosive metal. Like if it interacts with water, if you put sodium in water, it will explode possibly. If you have chlorine, pure chlorine, not the kind exactly you put in your pool, but pure chlorine is a deadly gas. It's poisonous. Inhaling chlorine gas could kill you. So if you take this explosive metal and this poisonous gas and make a compound out of them, what do you think you get? Michael? Yes, you get salt. You get something that you put on your food every day. So the properties of that compound, sodium chloride, which is salt, is much different than each of the elements on their own.
But then how does that mean? How do you get just sodium?
Sodium is an element, so you can find sodium in the earth. It's in the ground, in minerals. You can extract it.
Where could helium kill you?
I mean, because helium can displace air from your lungs. So, Logan?
Is salt a compound?
Yes, salt is a compound. This is salt, sodium chloride. It's made of sodium, which is Na, chlorine, which is Cl. So we have elements, they combine to form compounds. Our last two chemistry definitions are about two different categories of compounds. Charlie, you have a question?
Does it matter if you write all the letters?
Yes. It does matter. Charmy asked if it matters how you write the letters, uppercase, lowercase, and it does. For example, C, capital O would be carbon and oxygen. Capital C, lowercase o is cobalt, something completely different. So yes, it does matter. All right, so when we look at compounds, we split them into two categories. They can be organic compounds or inorganic. Now, when we talk about this, it's important. This has nothing to do with, like at the grocery store, organic produce and stuff like that. This doesn't have anything to do with that. So don't think about that when you're thinking about these two compounds. In chemistry, something is organic if it has carbon and hydrogen in them. If it has both of them, we say it's an organic compound. Like glucose, C6H12O6. It has carbon and it has hydrogen, therefore it's an organic compound. Trina?
So if it matters if you capitalize them, so do we need to capitalize them both? Or okay,
Oh yeah, it doesn't matter. It's just trying to emphasize that it has to have both carbon and hydrogen if it's organic. If it's missing carbon or if it's missing hydrogen, then it's inorganic. If it doesn't have both of them, we call it an inorganic compound. For example, water, H2O. It doesn't have carbon and hydrogen. It's inorganic. Carbon dioxide. It doesn't have both of them. It's inorganic. Silicon dioxide, salt, sodium chloride. Those are inorganic because they're missing the carbon and or the hydrogen.
What's SiO2?
Silicon dioxide. It's a compound you find like sand, for example.
Sand and rubber bands.
What's that?
Sand blow?
All right, so those are those are some basic chemistry definitions. We won't get any deeper into chemistry this year, but you will next year. All right, so let's talk a little bit here about nutrition and nutrients. So like you guys said at the beginning of class, a nutrient is something that your body can use in the foods that you eat. That's what a nutrient is. You just ate your lunch and you had, let's say, some of that broccoli that had a variety of types of nutrients in that. When you eat that broccoli and it gets digested, there are several different types of nutrients in that broccoli that your body is using. Okay? There's some protein. There's some sugar. Okay? There's some water. There are various vitamins and minerals in that broccoli. And those are nutrients. And we have a list of 6 nutrients that we need from foods that we eat. Okay? And I'm sure you probably had to memorize this for health. But they are water, vitamins, minerals, fats, proteins, and carbohydrates. So we'll talk a little bit about each of those and why we need them. Beginning with water. Water is crucial to living things. They must have water. Okay? And water is important for several reasons. We talked about these. What's one of them? Rachel?
To hydrate you.
Yeah, to keep us hydrated. And we need to be hydrated sort of because water is needed for dissolving various things in our body. And that's related to transport. You know, our blood is mostly water. We have fluid that's throughout our body that dissolves and transports things. Right? And without water, we can't have those things. It's also important for our bodies to get rid of waste. Our kidneys work by taking waste products from our blood, mixing them with water to form urine. And those waste products, it's important that they're removed from our body. If they're not, then we can't survive. You have to get rid of those waste products from your blood in order to stay alive. And water is an important part of that. Michael?
Isn't there like some part in like your, not some part in your body you only need 25% of?
Of like organs? Yeah, I mean certain organs like your liver and so on, you can live if part of it's not functioning or part of it's damaged. You can still, or you can live with one kidney versus two that you normally have.
You
Yeah.
can live with one too.
Yep. Yeah. Logan?
What's the difference?
All right, shh. Guys.
Like, why is it if you drink more water, it's more clear, and if you drink like
Because your body is, your kidneys are very smart about, your kidneys regulate how much fluid's in your body. If you have lots of water, then your kidneys say, okay, we got plenty of water, we don't need to hold on to much of it. And so most of that water that's extra, they just get rid of in your urine. And your urine's very clear. But if you are somewhat dehydrated and your body doesn't quite have enough water, your kidneys, rather than sending a lot through your urine, your kidneys will hold on to it more. Okay? And the urine that a person produces is more concentrated. It's less water and more of those waste products. So your kidneys are working to maintain the proper amount of water in your body. All right, vitamins and minerals. Nikita. These are nutrients that we need in fairly small quantities. Okay, we only need a little bit of them. And they have lots of different functions. We're going to talk about the whole list of vitamins and minerals that our bodies need and what they're used for. But we need these minerals and these vitamins to prevent us from getting what we call a deficiency disease. A disease when you don't have enough of a certain vitamin or a mineral, and it can make you very sick.
And don't you have to take like vitamin pills? No.
I mean, you could take vitamin and mineral supplements, you know, like a pill that you take each morning that sort of has a combination of lots of different vitamins to be sure that you're getting the proper amount. Okay?
Like if you don't have enough iron, isn't it like your liver starts to shut down?
Well, you can get anemia. We're going to talk about that. That's for tomorrow. All right, also, another nutrient that we need in our diet is fat. And fat is a excellent source of energy. Fats, in comparison to carbohydrates and proteins, that has the most energy per gram. So by eating fats, we can get energy. And also our body stores fat in our body. Okay? And that fat is important to help insulate our body, to cushion our organs. Our organs are all surrounded by a layer of fat that helps cushion them. Also, certain vitamins that we need are only dissolved in fat. So if you don't have enough fat, you can't get those vitamins. So fat provides several important functions in our body. Protein is another important nutrient. So in terms of sources, fats, you know, things like oil is 100% fat. Butter, meats, cheeses, certain vegetables have fat in them, and that's where we get those fats in our diet. Proteins we get, you can get from dairy products, from beans, legumes, from meat, obviously. And so protein is also important. Protein, most of our body is actually made of protein. Like our muscle is mostly protein. Our skin, okay, is mostly protein, our connective tissue. And so this protein is important. We can get energy from proteins that we eat. They can be broken down. We can get energy out of them. But in our bodies, those proteins function to help repair tissue. You know, if you strain a muscle and damage it, to rebuild and to fix that muscle, you need protein. Protein's also important for growth. So for you guys, now the time in your life when you're actively growing, you need protein to elongate your bones, to increase your muscle mass, and all those things. So protein's an important nutrient in growth. You know, people that are working out a lot and they want to replace and build up muscle tissue, they will need protein in order to do that. Jaden?
Like, if you're a vegetarian, how do you get this protein?
Like dairy products, beans, things like that, vegetables. So there are proteins in those other foods.
But what if you're vegan?
Then you probably get it through beans, you know, through those vegetables rather than animal products. Karina?
So like, say you're like small and like you want to grow. So what if you like eat like a lot of protein?
No, so here's the way it works. So if you are, so you have a certain height that your genes say you can grow to. And if you have good nutrition, you can reach that potential. If you have poor nutrition, you might not reach that potential. But eating extra is not going to allow you to go beyond what your genes say you could be. So if your genes say your maximum height is going to be 5'10", you could eat, you know, thousands of grams of protein. You're not going to go beyond that. But if you don't get enough of certain nutrients, you may end up below that. Michael?
Why does coffee sound
It doesn't really. It's just something people say. All right. And finally, carbohydrates. Carbohydrates, there's lots of types of carbohydrates. Two big groups of that are starches and sugars. And sugars are smaller carbohydrates. They're more easily used by our body, whereas starches are larger molecules. They need to be broken down to be used. But they're both excellent sources of energy. Carbohydrates' main function in our body is to provide energy. And so you may know, if somebody's going to be running in a road race or something, a marathon, what do they like to eat the night before?
Chicken.
Pasta.
Chicken.
Pasta is rich in starch, and so their bodies can store that energy and use that in their